Good morning, and thank you for attending to the presentation of life cycle and of electrical and electronic waste. This is an approach to the circular economy. The work is prepared by Luz-Angelica Rodriguez, Omar Parra, and Enrique Estupiñán, who is talking to you. The agenda that is going to be for the presentation is first one, why the WEEE, the EPR principle, the WEEE data, the state of the art of most of the components, the research question, why we are interested in this topic, the description of the model that we created, the scenarios with the policy that we developed and simulated, the results, and the conclusions. So, electrical and electronic waste. The prioritization means that the waste generated by electrical and electronic equipment is one of the fast growing in the world. We generate more than 8 million tons per year, but only recover 20%. Most of the components of the electrical and electronic equipments contain some elements that are scarce and that the mining of the natural resources could affect the environment. So that's the reason why circular economy comes into the hope. It could recover this material and replace the raw material, reducing the effects on the environment. The extended producer responsibility is a policy intended to cover the life cycle of the product. It could produce improvements on the product systems. It was designed, invented or implemented as an eco-design principle, but now the European Union is using it for the closing loop, collecting and post-processing the products. As a comparison between the European Union and Colombia, we see that 4 kilograms per capita is produced in Europe countries. In Colombia, we produce 5.3 kilograms per capita. In Europe, the collected quantities are 5.6 kilograms per capita, and in Colombia, we don't have an official data that shows how much of the produced is collected. Whenever we talk about electrical and electronic equipment, we think that there are many materials that are valuable inside the appliances. We could find in large appliances base metals, also in small appliances, and even in some lighting bulbs. There are precious materials that are in the IT equipment in a household, like routers, set-top boxes, and also in the circuit boards. There are plastic coming in large and small appliances, and also in IT equipment. The glass can be found in some televisions, CRT even, and lamps. There are some aspects, technical aspects and socioeconomic aspects related to the WEEE. In the technical treatment, we can find some chemical treatment and some kind of heating treatment process. Also, machinery that is involved, but it should cover most of the environmental effects on the treatment of the waste. On the hand of the socioeconomics, we need to focus on the prices of materials. This covers the hazardous materials, this covers also the valuable materials, but also they are related to the way that the waste is collected, the labor that is required to recover these materials, and also some incentives to companies that use the most adequate technology to recover it, following the national standards and international standards in environmental and other standards. Also, there must be a lot of research involved in these socioeconomic and technical aspects. What are the actors and responsibilities on the life cycle of the electrical and electronic equipment? We started with the producers that design, uses raw materials or recycled materials to produce the equipment. We introduce here the producer responsibility organization that links the producer with the end-of-life organization, the ones that are doing the end-of-life recovery and processing and treatment. Of course, there is an actor that is the government and the municipalities. Those implement the legislation and the regulations, and also the collection, most of it, and the consumer that makes the decision on when, what to buy, and when, what to discard, to dispose. In Colombia, we don't have all these actors. In Colombia, of course, we have the producers, we have the consumers, but we lack this organization that bridge the producers and the end-of-life organizations. Government also plays our roles, but not municipalities. In Colombia, we are 50 million persons. We generate, as we stated, 5.3 kilograms per capita. There is a national decree that rules all the collection and the recovery of materials. It is from 2018, and it was in force in 2019, and then comes the pandemic years. 36 companies are related to the WEEE recovery, and they have license to operate, but most of the collection are performed by informal recoverers. So, which are the most important household appliances that we studied? There are the refrigerator, the lamps, the televisions, and electric showers, according to the government agency, that is UPME, that shows how are the energy consumed by these appliances. We see that between the study in 2012 and the study in 2016, there is only a big difference between televisions. It was 13% and now it's 20%. The most important energy consumption comes from the freezers, the refrigerators, and of course from the lighting bulbs. The penetration of these three appliances are bigger than the other ones, are around 90% or over 90%. We included here electric showers, but we didn't study it in our model. Our research questions look for the policies that could increase the recovery material using the extended producer responsibility principle and allowing the circular economy to be placed. The model that we propose is a bit complex, not so much complex in this causal loop. We see in the top part, we see the part that is related to energy. It contains the price of energy, the energy efficiency of the equipment, and also it includes how it affects the average renewable rate of the equipment. On the right-hand side, we found the loop that it is related to recycling. We have the recovered material, the material that is hazardous and should be disposed properly in, and the part that could be exported to other countries. Of course, we have the landfill, and in the landfill we have the fee associated to it, and it affects also the price of the new equipments. In the center, we found the new electrical and electronic equipments that could come from national production or international productions, and it is affected by the population that wants to buy these equipments. We see also the loop that is related to the EEE in households and the reuse of the households. We see balancing loops and reinforcing loops in the model. The basic model shows us that the trend growing is present in all LED televisions. We see also that the sound associated with the televisions and music and streaming is also increasing. We see that the freezers also increases in time, and the one that is decreasing there is the CRT televisions that are getting to end of life. In the right-hand side, we found the distribution of the lamps, and we see that most of the technology in 50 years is going to be LED, and the other one, incandescents and fluorescents, are going to disappear. The scenarios that we simulated are 5. The first one is the reuse of the electrical and electronic equipment. This means to extend the life of the normal life of the equipment. The second scenario includes the fee for the end of life. The third scenario involves the formalization of the recycling. The fourth scenario is the increase in the energy price in order to reduce the consumption and to make better the energy consumption. And the final fifth is the information to the consumer through the energy efficiency label. As a result, we found that the best scenario in results are the third scenario, the one that is associated with formalization of the recycling. It reduces the material in landfill. It also recovers more material, valuable material, and increases also the collection of hazardous materials, avoiding it to get into the environment. The other one that is interesting is the scenario that involves the energy efficiency labels that reduces the consumption of energy in almost 30%. The ones that produces almost no result are the ones that involves the reuse as a policy. And in the sixth scenario involves the implementation of all the policies from 1 to 5. As a result, for the materials in year 50, we see that most of the material are ferrous, metals, and plastics. But the ones that are more valuable are gold, barium, some copper, and from the collection, in comparison to the base scenario, the third scenario shows an increase of almost 2 times the material and 2 times the value of the material recovered. When we simulated the sixth scenario, we see that the amount of material is almost triplicated, but the increase on value just is not increasing further than $1,280 million. So as a conclusions, we think that the formalization scenario is the best individual results. We think that the link between the producer and the end-of-life organization must handle all the collection, transporting, all the fees, all the arrangements to make it better. The advanced recycle fee needs to be implemented in order to compensate the cost. The best way to implement it is that only one company do the recycling, and the collection must be performed by municipalities. If anyone wants to affect the energy consumption, it should be done through energy efficiency labels. And the synergy of all the scenarios is the best result in total. It increases the recovery valuable material to 96%, it increases the hazardous materials to 57%. The reduction in the energy consumption is 36%, and the sales of new EE even increases in 10%. The reason that why we think that one company should deal with all the recycling is that the cost involved are really high, and it needs to collect a lot of material. So whenever it has more material recovery, it has the possibility to recover more material. Thank you very much, and we are expecting some questions.